Good morning, AP Calculus. In this video, we're going to look at how to define and write a piecewise function. Take a look at the word problem I have on the board. Let's go ahead and get started. Sylvester has a $25 gift card to pay for video game rentals. The amount he has remaining on his gift card after each rental is shown in the table below. Write a piecewise function or piecewise defined function that represents the balance remaining on the gift card f of x after each game rental. Okay. Once again, the key to this problem is going to be this part right here, the piecewise defined function. And all that really is it's two functions existing at the same time, or it could be more, it could be 3, it could be 4, it could be 5, it could be 10. Hopefully we don't have to see anything more than 3, but it's a function that exists at the same time, or multiple functions that exist at the same time in different segments of our domain, which is, of course, this part right here. So the question is, where does this split or this change in our domain happen? Okay. The first thing we want to do is we want to look at our balance and see if we can notice any changes in the patterns in terms of how his balance goes down. So looking at the first point, we have go for $22 to 19. That's a change of -3. He spends $3 to rent a video game, therefore it goes down by 3. Looking at the next point, 19 to 16, and once again, that's a change of -3. So we keep looking at the rate of change, and we want to point out where there's a change in that rate of change. That gives us a big hint here. Okay, so 16 to 13, that's once again a change of -3. 13 to 10, once again a change of -3. 10 to 9, that is where our rate of change changes. So I'm going to draw a line right here between the 5 and the 6. And that's where our change in domain happens. Because right here between 5 and 6, his 5th and 6th rental, his balance changes by $1. Okay, same thing with going from 9 to 8. We have a change of $1, 8 to 7, change of $1, 7 to 6, change of $1, and then 6 to 5 is another change of $1. Okay, now the question is, how do we write this as a piecewise function? Well, we want to start with our basic notation, f of x. Okay, so it's a function in terms of this x value, this rental value, the number of rentals that he has. Okay, so when we write it, we're going to have f of x equals, and then we're going to use these curly brackets to define, hey, we've got more than one function that defines this. And here's what you want to do. If you think of it this way, if you think of it as a sequence, 22, 19, 16, 13, 10, you want to start with the first term, which is 22. And then because it's going down by 3, we want to do -3. But we also want to keep in mind that it's going down for multiple values. And that technically he started with 25 beforehand. Okay, but we don't see that reflected in our table here. So we're going to do this instead. We're going to say x minus 1. Now, the reason we do that is because we don't have the 0th value, so to say, reflected in our table. So we only know this 22 value here. So we want to start that, and then technically if we were to distribute the -3 and do -3 times -1 and then add it to the 22, we'd be back up at 25. But this is a simple way of writing defining a sequence in terms of here. Same thing goes for below. We start with the first value we know, which technically is 10 in our sequence here. So we do 10 minus, and then because it's 1, we can either leave it alone or we can just write it as 1. And then we'd write the same thing, x minus 1. Now remember, a piecewise function has different domains. So the first thing we want to do is define the domain for the first cycle, which is between rentals 1 and 5. So we're going to say that x is between +1 and +5. Okay, and then below, for the next one, we want to include everything after that. So that would be technically between 6 and 10. So we're going to write a compound function for that. Okay, so and then we separate it based on semicolons here. Okay, so that's how we write a piecewise function. Is we look at the table that we're given, and then we go ahead and we find that value. Now, if we were to graph it, for instance, let's say we wanted to graph this. I'm going to draw a rough graph here. so we get an idea of what this looks like. Okay, so my rentals, let's see, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then let's say we go up by, let's go up by threes, why not? So 3, 6, 9, 12, 14, or 15, 18, 21, 24, 27. Okay, so at 0 rentals, so once again, I'll put this up here. So 3, 6, 9, 12, 15, 18, 21, 24, 27. Okay, so now, I'm going to make this a little bit bigger here so we can illustrate it a little bit better. So when we go to graph this, we start at 25, which is that right there. Let's undo that. Oops, wrong slide. Take that a little bit smaller here. Okay. So that's our first point right there. Don't mean for it to be so big, but not much I can do about that right now. Oh, let's try that. Oh, there we go. It goes away now. Okay. So 25 is about right there. Okay. After his first rental, he goes down to 22, which is just below 21, just like that. Same thing goes for 19. 19 is just below right here. Why did that go away? Okay, that's weird. Okay, and then for his third rental, he goes down to 16. And then for his fourth rental, he goes down to 13. And then his fifth rental goes down to 10. Okay, now if we were to connect these with the line, notice how it's pretty steep slope there. But now, once we go to the other side, where the rate of change changes, so now we're looking at going from 10 to 9, and then 9 to 8. Once again, this is roughly 8 to 7, 7 to 6, and then 6 to 5. We notice that the slope between those points is not nearly as steep as the original. Okay, so that's how we can tell if we have a piecewise function. Is usually there's a change. If it's a linear function, there's a change in the slope somewhere, or it just seems like something's off. Okay, so this is all we have to do for piecewise functions when it comes to graphing them as well as defining them.